let's talk about something you do every single second of every single day, perceiving the world around you. We're going to find out that what you think you see isn't just a simple recording of reality. Oh no, it's an incredible, complex movie produced, directed, and starring your brain. So let me ask you a pretty fundamental question. Is what you see really there? Is your perception a perfect, crystal clear window into the world? Well, the short answer is nope, not even close. And the long answer? Well, that's what we're about to get into. All right, let's put this to the test right now with a classic illusion. Take a look at these two lines. Come on, which one looks longer? Your brain is probably screaming the bottom one, obviously. But here's the twist. If you actually got out a ruler and measured them, you'd find they are the exact same length. Wild, right? That isn't a mistake on your screen. That's a feature of your brain, proving that what you see is an interpretation, not a carbon copy.
So how does your brain pull this off? How does it build this whole interpretation of the world? Well, it's got this secret toolkit, a bunch of shortcuts and rules that work so well you almost never even notice they're there.
Okay, first tool in the kit is something called perceptual constancy. This is your brain's amazing ability to know an object is the same even when the information hitting your eyes totally changes. For example, think about a door opening towards you. The image on your retina literally changes from a rectangle to a trapezoid. But do you ever think the door's magically changing shape? Of course not. That's your brain's shape constancy kicking in, just going, nope, still a door. What's absolutely mind-blowing is how your brain creates a 3D world from the flat, 2D images your eyes are sending it. It does this using a whole host of depth cues. Some of them, called monocular cues, work with just one eye. You know how train tracks seem to get closer together in the distance? That's your brain using linear perspective. Or when one object is blocking another, your brain just knows the one in front is closer. That's interposition. It's using all these little clues all the time to build a rich 3D model of reality. But having two eyes, that's a real game changer. That gives us binocular cues. See, each of your eyes captures a slightly different view of the world. Your brain takes these two images and masterfully merges them. And the tiny difference, the disparity between them, is this super powerful clue for figuring out exactly how far away something is. It's literally the magic that makes 3D movies pop out at you. Okay, so with all this raw data flooding in from the eyes, how does the brain actually turn it into something we recognize, like a coffee cup or a friend's face? Turns out it uses two very different but complementary strategies. So on one hand, you've got bottom-up processing. Think of this as being data-driven. Your brain takes in all the little sensory details, the lines, the colors, the textures, and builds them up into a complete picture, kind of like putting together a puzzle without the box lid. Then you've got top-down processing. This is totally concept-driven. This is your brain using all your past experiences, your knowledge, and your expectations to interpret what you're seeing. It's like having the puzzle box lid from the very beginning. And here is a perfect everyday example. You see a sign like this. Your brain doesn't need to slowly sound out ST blank P. No way. It takes a massive shortcut. It sees the red octagon, it knows the context of being on a road, and bam, your knowledge and expectations immediately fill in that blank. Stop. That's your top-down processing working at lightning speed. Now, these systems are incredible, but they're not foolproof. And actually, looking at what happens when these systems break down gives us a much deeper appreciation for just how amazingly they work when they're running smoothly. Let's consider a condition called agnosia. Now, the crucial thing to understand here is that the person's eyes are working perfectly fine. The data is coming in loud and clear, but the brain's ability to understand or recognize that data is damaged. It is a failure of recognition, not a failure of sight. Just how profound is this? Check out this quote from a case study by Sigmund Freud. It's just bizarre. The patient could describe the individual features, the two circles and a crossbar. The bottom-up details were getting through, but that top-down ability to just go, up, that's a pair of glasses, was completely gone. The recognition circuit was just broken. Then you have something like optic ataxia. In this case, a person can see an object, they can even recognize what it is, but they can't accurately reach for it. You know that feeling of fumbling to put a key in a keyhole in total darkness? Imagine that, but in broad daylight. Their where or how-to visual pathway isn't working right. We also see some really interesting issues when it comes to color perception, and it's really important to separate two different things here. Color agnosia is a recognition problem. The person can see colors perfectly, they just can't name them. Color blindness, which you've probably heard more about, is a problem with the eyes themselves, a genuine difficulty in telling certain colors apart. What's really fascinating is just how specific these issues can be. The most common types of color blindness have to do with red-green or blue-yellow perception. It's all caused by problems with the special cone cells in our eyes that detect different wavelengths of light. So for someone with protanopia, for instance, the world is just missing a whole range of vibrant red hues we take for granted. Okay, so after seeing how incredibly complex this whole system is and how it can sometimes fail, let's kind of reframe this. Your perception isn't just some passive sense, like a camera just recording whatever's in front of it. It's an active, powerful, and dynamic skill your brain performs constantly. And this really gets to the core of it all. Your brain isn't just reacting to the world, it's actively predicting it. It's using every bit of your past experience to make a continuous best guess about what's out there, and then it's updating that guess in real time based on new information from your senses. It's a superpower you are using every single moment of every single day. And you see this superpower in action absolutely everywhere. When you're driving, you are constantly making thousands of tiny perceptual judgments about speed and distance. Studies show that when athletes are on hot streak, they literally perceive the ball or the goal as being bigger. Even your physical state changes what you see. A hill looks way steeper when you're tired. Your reality is flexible. So I want to leave you with this one final thought. The very same shortcuts and predictions that allow your brain to build a stable, useful reality so efficiently also mean it has to be filtering things out. It has to be making assumptions. So if your brain is the architect of your entire experience, what are the blueprints leaving out? What are you not seeing?